Today, we're gonna see how aluminum parts like this one are made. This is a CNC mill, which stands for Computer Numeric Control. But think of it as the opposite of a 3D printer. Instead of adding material to make the shape that we want, it removes material from a block using a tool similar to a drill bit to give us the shape that we want. I'm gonna show you how all of this works from start to finish. I'm here at JLC's CNC factory in Zhuhai, China. A huge thanks to them for flying me out and giving me such complete access to the factory. They have a variety of machines here, 75 in total. We're gonna start with one of their simpler machines that they run 80% of their jobs on, and then we'll go look at some of the more complicated and cool machines that they have. But first, let's head upstairs and talk to the engineers to see the very first step in this process. I'm here with Mr. Yang, who's one of the engineers here at the CNC factory.
当工件来到我们自己手上的时候，我们会根据每一个工件的特性进行去工艺的拆解啊，然后再根据软件给它编出 NC 的一种程序代码，直到上面的机床上面去。首先，面对产品的时候，我们会大致的把它分成几大类，像轴承类、板类，还有块类，还有一个就是异形类。我们会把它拆解出来，形成不同的工艺流程，啊，然后就根据产品的一些形状，我们去判定它适合某一种工艺的角度去接工。
Mr. Yang, thank you so much for spending all the time to explain this to us. This has been super helpful. We're gonna leave you to work and head off and go see the next step here. So thank you very much. Parts start their life here in the materials warehouse. They have all sorts of materials. This is brass. They've got large blocks of aluminum down here, a copper here, and then over here we've got polycarbonate. This is acrylic. We have FR4 fiberglass, like in circuit boards. This is POM, another plastic. Bakelite here. This is really common to see fixtures in factories made out of this. I think because it's cheap and easy to machine, but I'm not totally sure. And then this is all ABS plastic here. They pull the raw stock here from the warehouse, and then it gets sent over to the saws for cutting down to rough size of the part. That was super fast. I thought this was a bandsaw. It was gonna take a long time. No, it's actually a circular saw underneath this guard. It's a blade about this big, and they can move real quick with it. And then this gets sent downstairs to get put in a mill. So one of the first steps is going ahead and making sure that the right tools are in the machine. There's a special drill bit for this job that he's loading right now. He's taking out the old drill bit out of the tool holder. This is what the machine will grab with the spindle will grab this, but the bit actually goes into the collet here, and he's swapping those out. This machine actually has a bunch of standard tools in it, and this is the list of what should be in this machine the whole time. From 15 to 21, it's whatever the job requires. So those are open slots that they can put specific tools in. So he's putting this specific drill bit in 17. And then I think there's also a tool that goes in 21 that's not normal. Yeah, here. So this is a big facing cutter, big facing mill. We'll see, it'll cut the top of the face real flat very quickly. The next step is to check that the raw material he has is actually cut to the right size, to make sure he didn't grab one from a different job or something like that. I assume he's also checking that it's the right material. Now he's loading the material in the vise. This is work holding. This is an art when it comes to CNC. How are you gonna hold material? This particular part here has a very square bottom. And so that makes it very easy to hold in a vise like they're using right now. But you can imagine part shapes where the jaws of the vise would get in the way of cutting that sidewall. So there are other clever mechanisms to use for this, and this is something the engineers upstairs specify. So now he's loading the G-code, he's loading the program that the engineers generated upstairs, which actually tells the machine what movements to make, at what speed should the end mill be spinning, etc. And it's actually the same programming language as runs on your home 3D printer. It's all the same commands, more or less. There's some variation between manufacturer. But these are basically telling the machine what tool to load, how fast to spin the spindle, and where to move and how fast. Oh, this is interesting. So he's actually using an end mill to measure where the part is. So he's just bringing it in right up to the point that it starts cutting. I think he's listening to it and then hitting 0 on the program. And the machine doesn't know exactly where in that vise the aluminum is sitting. And so he's essentially telling the machine where the corner of that block is in all of the dimensions. So he's doing all 4 sides and telling it the limits of the work. And then he's also going to touch down on the top of it. Oh, yeah, that one definitely spit chips. Okay. It's funny because there is actually an edge finder in here, but he's not using it. And this is actually pretty interesting. I've never seen anybody do this before. He's using another end mill of a known diameter and doing a go, no go check. So he's basically trying to roll it underneath the end mill to get the end mill zeroed to a known height. Basically the known diameter of the bit he's using to check. So there is an electronic tool setter here as well, and that's the tool's probing off that. So it's an electronic sensor that measures the height of the tool off the spindle so that the machine knows where the end of the tool is. So he's using that for the tools, but he's measuring the height of the block of aluminum using this go, no go test. So he's bringing the tool down in little increments and then rolling this bit underneath it to get an exact measurement of where the height of that aluminum block is. Very smart. I've been learning a lot that I'm gonna apply to my own CNC mill in my shop. Lots of tricks of the trade here. Our man here is very industrious, and I'm having to ask him repeatedly to slow down so that we can get footage of stuff. He's ready to run this machine, which is good. It's just making it hard. Finally, we turn on the coolant here to keep the chips out of the way and keep the cutter cool and start the job. So I had them pull off a panel here so we could see in the side. Normally this would be all closed up because this thing makes quite a mess. The very first step here is this big face mill. It's gonna come in and clean off the top of the part and make sure it's totally parallel and flat. And then we'll come in and start roughing out material with end mills. We've milled the bottom of this part now. The machine milled the top face here with a face cutter, that big, huge black. It then came in with a regular end mill and carved out the edges here. It did it in 2 passes. So it did a roughing operation here where it took out most of the material. And then it did a finishing pass where it came in and removed just a tiny bit to get a really nice finish on this edge. Then it came in and drilled these 2 holes. And then lastly, it used a chamfer bit to put a countersink on the holes where a screw head would fit in probably. And then finally it came around this outside edge with a chamfer bit and put a tiny bit of a chamfer here. And the reason to do that is to remove any burrs that might have been raised by the end mill. It would raise a rough edge that would be sharp on your fingers. It would cause all sorts of other problems. So they just take off a little bit of an angled edge there. So now this is nice and smooth. Now he's gonna flip the part over and hold it in the vise again. This time he's gonna have known surfaces to register it in. We know that this surface is parallel to this surface at a right angle to this surface, and we have an exact width here. When we have the rough stock, we don't know exactly that everything's perfect. It might be a little bit bigger, a little bit smaller than it should be. It might not be totally parallel, but now we have a perfect reference surface to finish the top of the part. Now that he's flipped the part over, he needs to remeasure where it is in the vise because it undoubtedly has shifted. And I was actually really curious how he was gonna do this because he's actually got an underhang and I didn't know how he was gonna get around that. It's pretty clever. He's using a parallel, which is a precision ground piece of tool steel of a known width. He's sticking that underneath the underhang and bumping it up against the wall. And then he's using an edge finder. And an edge finder is a very cool tool. It's very simple, but it's very brilliant. So I've got an extra one here. It's a cylinder of brass. This is a very precise known diameter, both here and here. And it is attached to the shaft that's in the tool holder via a spring, which allows it to move around off center. And the off center part is very important. You start with it off center and you spin this, and this will very visibly wobble. And then as you push it up against a wall, an edge, it gradually brings it into center until it's perfectly centered. And when it's perfectly centered on the shaft, it'll stop wobbling. And with a little bit of math, you can subtract off the radius, subtract off the width of that parallel, and then you know exactly where that edge is. And so he's doing that on all 4 sides. And with that, he knows exactly where the part is. It's really smart. I'm not sure I would have known this, which is why I'm not a full-time machinist. And here's the finished part. This looks great. The top of this has a lot more complex geometry than the bottom did. This has some more organic shapes, some curves, things like that. The top took about 45 minutes to mill, while the bottom was only like 4 or 5 minutes. And that's because 1, we're removing a lot more material, but 2, we're carving along these organic curves, and that takes a lot longer. But believe it or not, this is actually a relatively simple part for CNC. And I'll show you why. Just grabbing a random end mill they have lying around. This is a 3-axis mill. And what it means is the end mill or the bit can move in 3 directions. It can go up and down, it can move side to side, and it can move forward and back. And we can mill anything that it can reach from that vertical position. What it cannot do is it cannot come in sideways, and it cannot come in at an angle. And so you could imagine if this part had holes in the side, we'd have to do 1 of 2 things. We either would have to turn this on its side, reclamp it in the vise, and then do our holes, or we'd have to use a machine that has more axes, right? That can move the part to a different position and then come in and mill it. This had 2 different setups. The bottom, where we milled this, and we milled the sides, and we milled the holes, and then we flipped it over and we did the top. That's 2 setups. Every time that has to be done, a human has to come along, flip it. They may be busy somewhere else while this machine finishes up. So ideally, you minimize the number of setups on the machine, maximize your machine time. So we're gonna see some other machines that can do things like mill holes in the side or do underhangs all automatically. If the part is a little bit more complex, then they use what's called a 3-axis plus 2-axis machine, or a 3+2 machine. This is the part they're running right now. And you can see here, it has holes drilled in the sidewalls on a bunch of different sides, and it's not totally square. So they need to be able to hold this part at a bunch of different orientations. But once they get it to a given orientation, they can just drill the hole and they're good to go. The reason this is called 3+2 and not 5 is that the 3-axis mill is not synchronized with the 2-axis work holder. They can position the part anywhere they want, but once they position it, they need to hold it in that position for the mill to come in and do whatever it's gonna do. Then, once it's done with that operation, it comes back out, they can reposition the part, hold it steady, come in and do some more milling. The last step, you've got something really complex, is a 5-axis mill. So this is an example of something that you can only do on this machine. And this is because it has these really complex curves that are also underhangs. So the only way to reach in here is by moving both the part and the tool at the same time in synchronization with each other. They only have 1 of these machines right now. It's not actually that common to need this, but when you need it, you need it. So let's go ahead and take a look here. I'm gonna have him turn off the coolant for a little bit and so we can open the door without it splashing everywhere. They're running with a lot of coolant, both to keep the tool cool and to flush away any excess chips that come out that would leave marks on the part. That is so cool. A mill is great for parts that are square, rectangular, organic shapes, things of that nature. But what happens if the part is cylindrical or has a roughly cylindrical profile? Something like, say, this cylinder here. It's actually got a thread cut in it here, but again, mostly cylindrical. Or even something like this, that mostly round. You really want this inner part here to be concentric with the outer part, even though you might have some details like this on the edge or holes drilled in the side, things like that. For a part like this or like this, instead of using a mill, you'd use a lathe. And the big difference is, in a mill, you would hold the part stationary and you'd spin the tool around like this. You'd come in and spin the tool, and then you'd move around the part and cut it. On a lathe, you hold the tool stationary and you spin the part, and the tool cuts shavings off the part. Now, I'm sure there are machinists out here that are gonna argue a little bit with what I'm saying, but in generalities, this is true. In general, you would use the lathe for round parts, mill for anything that's not totally round. Just like on the CNC mill, you have an automatic tool changer here. They can load up a whole bunch of different tools. This one's actually a little bit fancy, and I've not seen one of these before. This one actually has automatic drills as well, so it can actually drill holes off center here very easily with the part stationary. So they'll hold the part like this, and they'll come in with the drill on the edges here. Not all lathes have this. They actually also have 2 lathes plus mills, so it can do anything that a mill can and anything that a lathe can for parts that need to be both very cylindrical and have some details milled into them. It's very cool stuff. Oh my God, this is so cool. It's so smart. This is a vending machine for end mills, for bits for the CNC machine, so that workers, when they have a tool wear out on their machine, can just come and get one. They don't have to talk to anybody. They can just get what they need. It uses facial recognition to track inventory and figure out which workers are requesting which tools, so they can detect any anomalies in case workers are smuggling tools out in their pockets or something. I love this. This is one of those things that just really contributes to worker productivity and worker autonomy, which is really what you want in a place like this. And this is where they store the more specialty tools and where they're storing tool holders. So these are not cheap. This is thousands of dollars worth of tool holders at least. And then it looks like they've got a bunch of end mills here. I thought these were drills. There are some drills here, but these are mostly end mills. They've got some specialty undercut cutters. This is for cutting a groove in the side of something. And then they unlocked these cabinets. These are where they're storing, yeah, you can see there are entire bins of other specialty cutters. This is easily tens of thousands of dollars worth of tooling. So this is a locked room, and not just anybody can wander in here and walk off with a pocket full of tooling. Look at these. Some fancy finishes on those. I would imagine this is for specific materials that need a fancy finish. They're currently testing out this really cool robot arm for loading and unloading parts. So all of these machines have automatic tool changer for loading and unloading tools, but you still have to have a human come and unload and load parts and material. This can load a bunch of different small parts on this rack and then load them into the machine, chuck it up, do the milling operation, pull it back out. It means they can run the machine much more efficiently. They can run many more parts per hour. They're still dialing this in. This is not in full production yet, but it's pretty sweet. It looks like they've got compressed air on the front of this arm for cleaning off the part, cleaning off the chuck that they're holding it in. And then each of these parts, see here, they've got a bunch of testing parts in here, but each of these parts has like a little mini vise, and then this can be grabbed by the chuck in the machine. And it looks like they've got it, I don't know if this is 5-axis or 3+2. It looks like maybe it's 3+2. I gotta make sure not to get whacked by this. It's pretty awesome. I think we're definitely heading to a place where a lot of machines would have this on there. I don't think they're gonna run this for every job that comes through here. It doesn't make sense, but if they've got small parts, or they've got a job that needs a bunch of parts that are all the same that can fit in a little vise like this, it makes a lot of sense. Very cool stuff. Next, if the part needs any threads in it, they will drill a hole in the CNC machine, but then they'll bring the part up here and use a tapping machine and a tap to thread the threads, to cut the threads in the hole. And it's a roughly manual operation, like a drill press. So this is the tap, and it's like a drill bit, but it specifically cuts threads of a given diameter. And this actually looks like it's an end tap. They're often a little bit more pointed than this, but this one would be used for tapping the bottom of a hole. Now that we have a machined part, we still have some finishing to do. You can see here, there are tool marks on here, and this is very smooth to the touch, but it doesn't look great. It still has marks where the end mills and other tools moved back and forth across the part. Not really what we want from an aesthetic perspective. We're upstairs in their finishing area, and they have a bunch of different options for the surface finish of a part. The first option is sandblasting, which you're probably familiar with, but it's compressed air and a real fine uniform sand that just gets blasted at the part. This is what it looks like here. It just looks like a really fine beach sand. And the compressed air blasts this at the part. It erodes away a very thin layer on the top of the part. And this does change the dimension of the part. So if you need something that's super precise, you wouldn't sandblast it. But it'll give you a nice uniform matte surface. And then you can do other things like anodization. They've also got a variety of sanders. This is a big belt sander for a really flat part. And then they've got a rotary sander over here that she's using on a part that's got flat edges, roughly square, rectangle kind of thing. But the real work happens by hand. This is the polishing team. They're sitting around a pool of fresh water here, and they're just going in there with little files, little bits of sandpaper, gradually buffing out every little last tool mark. This is ultimately what you have to do to get a nice finished part on something that is not flat or has complex geometry. I heard someone say once that manufacturing is a little bit like Soylent Green. It's made of people, and this is the perfect example. Ultimately, we often think of factories as being machines and conveyor belts and robots. And the reality is that a lot of manufacturing just happens by hand. It's not easy to teach a robot to polish custom parts that are all different. So ultimately, it's a team of people just sitting here, polishing one little bit at a time. Next, the finished parts come in here to the measurement room. And he's checking every dimension against the drawing to make sure it's exactly what the customer specified within the specified tolerances. This is actually a Mitutoyo, I don't know exactly what you would call this. I would call it a micrometer. He's using this because it would be very hard with a pair of calipers to get the internal height dimensions on this part. So he's using, this is actually a block of granite, and they use this because you can grind it very, very flat, so it can be a good reference surface. And actually, this is both a block of granite and this entire table is a block of granite used as reference surface with tools like this. I imagine that you can also use this tool by swinging it around to the outside. So if you have a much larger part that doesn't fit on this, you have space to work with it. He's also got a tape holder with a bunch of bolts to use as references for threads and make sure that they've got the right thread in them, the right size. And this is just making sure that the part they ship to the customer is what the customer asked for and within the right tolerances. And finally, they pack it for shipping. Now, they've built a crate because when you've spent this much time machining a part this complex and polishing it and everything, you don't want it to get damaged during shipping. This is actually aluminum, even though it's been anodized to look like brass. If you'd like to have a part machined by JLC, you can click the link down in the description.
When we were on this trip to China, the factory took great care of us, feeding us in their cafeteria during the day and taking us out to a number of nice meals at night. We really never had to think about food. But at home, I used to struggle with eating well because I get too sucked into projects and end up just eating crappy snack food. And the grocery store is a 40-minute round trip since I live up in the mountains. But a couple of years ago, I found a great solution. Factor delivers amazing fresh meals to my door every week. This is the first time they've sponsored a meal, but I've been a happy customer for years now. And it's not just me, a lot of the creators that I know who have done Factor sponsorships end up being long-term customers. I love these meals. They're completely fresh, not frozen, with a ton of great flavors that are constantly changing. You can choose between 35 different meal options every week, including meals for specific diets, ranging from calorie smart and protein focused to vegan and keto friendly. I was eating keto for a while because it really helped with my concussion symptoms. And eating keto can be really hard because of all the strict nutrition requirements that come with it, which makes shopping and cooking a ton of work. And it makes sticking to the diet a real pain. Factor does all of the work for me, and I know that the nutrition is gonna be correct and the meals taste amazing. If you want a more gourmet option, the Gourmet Plus plan has meals that feature premium ingredients like filet mignon, shrimp, and salmon. I just got this new salmon and shrimp meal that I really want to try out, and it's super easy to prepare. All you do is warm it up in the microwave and it's ready to go. So you take it out partway through, give it a good stir, just to make sure it heats up, and then you put it back in for a couple minutes and then it's done. All right, let's give this a shot here. Let's try one of these shrimp. That's good. So even after microwaving it, like these stay, you know, tender and not too dried out. It's really good. And then these are cauliflower grits, which I've had in the keto meals as well. Yeah, good broccoli. Yeah, I really like these meals. They also sent me some cold pressed juice. This is a gut greens with cucumber, spinach, and pineapple. Give it a good shake up. It's supposed to have a bunch of probiotics in it. Yeah, it's good. It's sweet, it tastes green. Yeah, I mean, I'm into juices like this, but this is great. I'm a huge fan of Factor. If eating well while you're busy with life and work and school and or your personal projects is something you struggle with like I do, I really encourage you to give Factor a try. Head to factor75.com or click the link down below and use code 50strangeparts to get 50% off plus free shipping on your first Factor box. That's code 50strangeparts at factor75.com to get 50% off plus free shipping on your first box. I'll see you again soon.